So it says, discuss the historical development of the periodic table up to the modern one in use. Discuss the contributions of any four named as scientists. Illustrate with a label diagram of the periodic table and briefly discuss the various groups or periods. Alright, let's start with the historical development. Now, in 624 BC down to 546 BC, a mathematician and astronomer named Thales, some people say it's Thales, he put forward that all matter is made up of water only. But when this was criticized, he said that yes, that water can exist biologically, geologically, and even physiologically and botanically. So, but it was more or less someone trying to think, well, it was not until a man named Empedicus, he existed in the centuries of 490 to 430 BC. So he was the one that now said that actually matter is made up of water, air, earth, and fire. If you've watched Avatar long ago, the Four Nations, so Empedicus, he postulated this, and we've all heard of this in our philosophy class. This man think too much. Plato. So it was Plato 427 to 347 BC. So it was Plato that now said, in fact, these elements, these water, air, earth, and fire that Empedicus postulates to be the makeup of matter, that he agreed with it, that let us now call it elements. So it was Plato that said, let's give it the name elements, meaning elementa, that matter is made up of it, elementa. Now, there is another man from our philosophy class, if you remember, called Aristotle. Great thinkers of that generation. Aristotle, he existed in the centuries of 384 to 322 BC. And you need to know that Aristotle is very famous and a student of Plato. He was a student and apprentice of Plato. So Aristotle was the one that first grouped, or should I say, made the first attempt of grouping what was known as an element as in form of a table that will contain it, having it in, should I say, in a period where the properties determine how you group it. So he said that water is cold and hot and wet. Sorry, yes, the water is cold and wet, and air is hot and wet. Air is hot and wet. And he said that earth is cold and dry. Then that fire is hot and dry. So he now made a component table where you have the vertical and the horizontal, the row and the column. And what he did was to group this in such a way that the vertical column has the wet and the dry, and the horizontal column and the horizontal row has hot and cold. So he now puts it in such a way that air, fire, you understand, water and earth. So this was how he placed it. So he was the man that he was the first to group what was known as elements as proper as periodic table, more like property table. So, but this is what we call the medieval era. So the ancient days before Christ. But fast forward to 2000 after Christ, that is in the generation that we are, in the generation of centuries. So when you are being asked this name, Thales, Empedicus, Plato, and Aristotle, they started this. So then fast forward, even we have men like Democritus who said things about atom. So we now have the man, the first man to discover what we have as elements. The first known element that was discovered was by a man, a French scholar known as Antoine Lavoisier. And he did this in 1789. He did this in 1789. Now he was born in the year 1743. He died in the year 1794. As at his death, he was able to gather and catalog over 2 dozen, over 24 elements. Actually, when you talk about elements, all these ones you see Chemist giving all the credits to Mendeleev. That's because Mendeleev published it. But when it has to do with the person that played the most role in what elements and everything is, this is the man that we are supposed to be talking about. He was the man that first made the first grouping of elements into gases, metals, non-metals, and earths. So he was the man that made it, that grouping and the rest. So he said, this is how he discovered the first element. He said that if a particular substance can be decomposed, that is split into other particle or into other forms, that means it's not elemental. That means that there's something that make up that particular one. So he took water, he took H2O that the previous generation was calling element, and said that this water, he didn't know that water was H2O as at then, but he said that when passed over an ion, that when passed over an ion, he was able to get hydrogen and oxygen. So when he did this and he discovered this, he said that what he gets, that the particular gas he gets, which is this hydrogen, that this particular gas that he gets, that when he tries to burn this in air, that it still gave him this water. You get the point now? So he passed it over an ion, and when he tried to burn this particular gas that he got from the passing of this on over an ion, burning it gave him water again. And you know that in air is a belief that we have oxygen and nitrogen. So mixing it again with this still gave him this. So he said that these two that he found, which is hydrogen and oxygen, he tried to decompose it. Then he discovered that he couldn't decompose it. So that means that this is what is elements. These are the elemental ones because it can't be decomposed. And we know that elements are substances that cannot be separated by physical means. When you cannot separate it by physical means, it is called an element. And I told you that atoms of the same kind, yes, atoms of the same kind is what you call elements. So a compound, this is a compound. A compound is made up of elements, or elements make up a compound. The elements coming together give you a compound, while compound coming together give you mixtures. So he also said that if you take up air because air as at then was put as an element. He said that if you take up air, oh God, this Antoine Lavoisier, he's not giving the credit he deserves. The way they should be talking about him is supposed to be too much. But today, when you talk about chemist, it's always Mendeleev, Mendeleev. Anyway, money rules the world. He published it. He was more popular, and he was working at St. Petersburg as at then. But this Antoine Lavoisier, I'm saying he played so much role. So when he tried to work on air, he discovered that an attempt on air, that he was able to physically separate air into oxygen finely mixed in nitrogen. And when he tried to separate this oxygen and nitrogen, it couldn't. He couldn't. So he called these two elements. Before his death in 1794, he was able to discover over he was able to discover over 24 or is it 22 elements. And elements he discovered include antimony, iron, bismuth. The question can come, they tell you to list the elements discovered by Antoine Lavoisier. Good. This man really tried. Just imagine if this man did not come to this world. We will not have what we call elements. Maybe somebody will come and give it one name and be telling us to be using fire as elements, using water as elements. And you know that the way things are in this world is knowledge is power. Whatever you don't know, who knows in future? Because think of it, the generations of Plato and Socrates and Aristotle, they thought water, fire, air, and earth are elements. But who knows, in future, somebody can still come up and say that is no longer this, that is another one that is elements. That is why we need to be working hard. We need to be making research. God helping us. So what I'm listing out are elements that Antoine Lavoisier discovered in his lifetime. So lead, oxygen, nitrogen. So there you have it. There you have it. So this man, after him and his discovery, he tried to classify elements. He tried to classify his elements into gases, non-metals, metals, and earths. So another man that played a role in this is in 1829. He's a man named Johann. I find it hard to pronounce his name, but it's Johann Dabrenner. So in 1829. Now, he said that he recognized that elements have triads with chemically similar properties, such as lithium, sodium, and potassium. Sodium, lithium, and potassium. So it was, or in his discovery, he discovered it, but they were not sure. Now, the development of a periodic table came to life. It became more serious in the year 1860. In 1860, that was when an accurate list of atomic masses of elements, was published. Accurate list of atomic mass of elements was published in this year. Was published. Now, notice that I'm always talking about atomic mass and not atomic number. This is because in those days, this atomic number has not been discovered. The man that made the atomic number what it is what the person will call Henry Moseley. I'll tell you about him when we are discussing modern periodic table. So it has not been discovered. This atomic number has not been developed. That is having protons, neutrons, and electrons. So as at then, all these things, that is atomic number, nucleus, and the rest has not subatomic particles. Subatomic particles, better state, has not been developed. Subatomic particles. So you notice that after this man, in 1865, a man known as J.A.R. Newlands made the law of octaves. He postulated the law of octaves. So you see that these are places that Mendeleev took ideas from. So he said that he stated that chemical elements are arranged according to increasing atomic weights. Those with physical and chemical properties occur after each interval of 7 elements. That was his postulation. So it was now in 1869, after this, that a man known as Dmitry Ivanovich, a Russian chemist, Ivanovich Mendeleev, in this year, and that was in February of 1969, when he was working at St. Petersburg University. He published, in this year, he published his to become very famous periodic table. So he postulated this and he published it. So in that publication, he made it that he made room for elements that were not existing as at that time. So he had things like this, hydrogen, and where he noticed the law of octaves, where he noticed similarities, he grouped them to be together. So he had things like this, hydrogen, then there was no helium, then lithium, beryllium. So in 1869, and this man was born in 1834, and he died in 1907. So he made this publication working at St. Petersburg University. Now when he made this publication, he became very popular. Ask any chemist today who is the father of periodic table, they will tell you Dmitry Ivanovich Mendeleev, a Russian chemist. So he made this. So, and he made it based on atomic masses. I told you that in their days, atomic number was not there, and at times they regard anything like atomic number maybe as just a, should I say, a reference point, but they didn't take it as a serious case until a man named Henry Moseley in 1913. Right? Yes, in 1913, uh, uh, towards 1914, let's just say it's 1914. In 1914, postulated atomic number to be the number of proton positive charge in the nucleus. So in our next class, I'll be teaching you about modern periodic table. Then you will see this gift of God called Henry Moseley, who did not live so long. He died at the age of 27. When I think about this man, I think of how much he could have given to the world had he stayed with us. Because just within that years, he brought out a lot of things that old people won Nobel Prize for, but couldn't even account for it. He made it so profound. How much more? He died during the World War One. He volunteered to become a technical engineer. He left his work to volunteer to fight for British, and he was shot by a sniper and he died. When I think about him, anytime I'm thinking of these discoveries, and I remember that part, and with what he discovered, the thing touches me so much. So in our next class, we'll be dealing on the modern periodic table. So on record is always recorded as in 1913. That's when he put up this. So but in 1914, he said something about atomic number, and he gave laws which we call today as Moseley's law. So in our next class, we deal with the modern periodic table. So when he has to do with the periodic table that has to do with atomic mass, or the old periodic table, or the periodic table that gave us the foundation of the modern periodic table, this is the father of it, called Dmitry Ivanovich Mendeleev. So subscribe, share, like. We'll look out for our next video on the modern periodic table.